Hi, this is Jeremy Allison with Google, and we're incredibly lucky today to have one of the Java legends, Josh Bloch, with us. Welcome, Josh.
Thank you, Jeremy. It's a pleasure to be here.
So Josh works for Google, and we're going to be talking about a whole host of things, including Java. But one of the things we're going to have to say that we're not going to talk about, and I'm sorry if this is going to disappoint people, is we're not going to be able to talk about any lawsuits or pending legal matters. Okay? So I just want to lay that out there.
Works for me.
Yeah. So we don't... I think both of us have actually been deposed before.
We're not going to talk about this.
Well, okay, for different lawsuits, and we don't want to have that happen again. So.
Okay.
So, having said that, if James Gosling could be described as the father of Java, you've been described somewhat as the mother, or as I prefer to say, the kindergarten teacher of Java, perhaps. So, what exactly is it that you do for Google?
Well, why don't I start with what I did for Java and then talk
Sure.
about what I did for Google, because then you'll understand why
That works.
people call me a mother. So I designed a bunch of the core libraries in Java, I guess most famously the collections framework, and then various of the concurrency libraries, although Doug Lee did more of those than I did. And I was very active in designing the Java libraries and Java language extensions, from releases 1.1 through Java 5. And at Google, I've done a whole bunch of stuff, and what it has in common is it's all been related to either Java or API design or architecture.
That's application programming interface design.
Indeed, yes.
An incredibly important subject that I hope to ask you a little more about later on.
Yes.
But first of all, I'd like to say to you, you failed me, man. You let me down.
Oh dear.
I know.
What did I do?
Yeah, well, so it wasn't so much you as Java. I remember being a fresh-faced, or fresher-faced than I am, programmer, working actually on some proprietary code, some open source code, looking at Java and thinking, this is it. This is the future, man. All our desktop apps, they're going to be Java apps. I even had a bet with our VP of engineering that within 5 years, nobody would be writing native mode apps anymore. Everybody would be writing in pure Java. Everyone would be running Java on Windows, Mac, Linux. Nobody would care what the desktop platform was. And cats and dogs would be singing in the streets together. Unicorns would be flying down the rainbows to our homes to, toast our bagels for us.
And free ponies.
Yeah, free ponies. What went wrong?
Yeah, it was ours to lose, where ours was the Java platform, and regrettably we did not win that one. A number of things went wrong. In order to make that vision happen, we would have had to provide a good end user experience that was at least roughly comparable to what people were getting out of Windows. But
it was pretty good, Josh. It was pretty good.
Well, it was pretty good, but there were a number of things that weren't there, and there were a number of just sort of ergonomic factors that were wrong and are to this day. I mean, anyone who runs an applet knows that you still have to wait for the browser to come up. The whole sort of integration, platform integration, and more generally the kind of distribution, just how do you make it everywhere, how do you give it access to all the things that people want out of a rich desktop application, whether that is audio or video or whatever.
3D graphics.
3D graphics, yeah. They were slow in coming. Initially there were performance issues. Most of them have gotten solved, but amusingly the reputation continues to dog the platform. It is largely undeserved and has been for quite some time. But at any rate, I think that there was a market window, and Java did not achieve sufficient. Didn't get over that bar in the amount of time that was available for it, and instead it took off on the server side.
Yeah, because it is and I hate to say this, but it's true. It is a beautiful language to write in. I mean, it's expressive. It's, what was it, C++ without the guns, knives, or bombs. It's just a nice language to use.
Yeah, it's very nice not to have to worry about bus error core dumped, not to have to worry about buffer overruns and the like. I think, you know, a large part of its success was that it took, you know, these things that had been largely academic toys until then and brought them to the mainstream, garbage collected and type safe, and it was simpler. You know, C++. Yes. It's not just guns, knives, and chains. Yes, you know, hurting yourself is bad, but also there was just too much stuff there. It was not pleasant to learn and not pleasant to read other people's code, you know, Java initially was a much smaller, much simpler platform. Of course, over the years, it has grown its own warts. That's inevitable.
And that's one of the things that you're hoping to be working on, or that you are actually actively working on.
I am. Actually, I'm on the expert groups for Java 7 and Java 8, a little further out in the future. In fact, Java 7 released a public draft of the language changes. I think it's JSR, I'm going to say 343. And if you have any interest in that, you all should read those and send in your comments.
Yeah, I mean, the thing, I think Java, I guess if I was to look back and say, what did Java really achieve? I worked with programmers, they were good programmers, but for some reason memory management, that kind of thing, is incredibly hard for people to get straight. And, you know, I worked with people who produced horrible C and C++ code that would crash all the time. Some people would say I do the same. But move them... Well, I don't know, you have to look at our security bug fix errata, but you move them to Java and they become happy, productive, incredibly fulfilled employees producing, you know, millions of lines of really high quality code. And I think the platform has to have some credit for that.
It's a higher level language. There's a lot of, you know, scut work, as they say, that you have to deal with in C++ that you don't have to deal with in Java. You know, you mentioned memory management, and that's certainly a good example. And yeah, you know, you can write code that manages memory, and you can not have memory leaks in your code, but doing so requires a heck of a lot of self-discipline.
Yeah.
And not everyone has it. And you know, some people who have it can't be bothered. And when that task is automated, your mind is freed to work on other things. There are a few other things that I think are responsible for Java's success that are perhaps, you know, less frequently credited. One of them is JavaDoc. This is, you know, kind of a strange thing, but you know, with C++, libraries are often very poorly documented, and maintaining
you look
the
at the code to work out how it works.
Precisely, you look at the code to work out how, and the problem with that is then that the implementation becomes the specification.
Yeah.
The implementation has all manner of, you know, what were never intended as API. You know, there are just sort of implementation details, and all of a sudden they achieve the status of actual interface, and anyone, let's say, who does an alternative implementation has to, you know, have bug-for-bug compatibility, has to preserve the same behavior, even in ways that, you know, you wouldn't really want to preserve, and as a consequence, the warts are preserved, and sometimes you're unable to make things run faster because of the fact that you have to kind of preserve these strange behaviors. So I think that just having the documentation become part of the culture was, you know, a really important thing that happened early on in Java, and I think that that helped it succeed. Another thing that helped it succeed is that it's always had halfway decent libraries, and they've improved a lot over the years. You know, so for example, let's say in the initial release of Java, which I was not involved in, I arrived in '96 in time to contribute to the 1.1 release, but the 1.0 release I was not involved in. They had, you know, basically two data structures there. And they were hash table and vector. If you're only going to have two data structures, those are the ones to have.
Yeah, it's true.
Incredibly useful,
a lot of things
incredibly important.
Yeah.
And you contrast this with the STL, where for years it didn't have hash tables, you know. Ouch.
Yeah. So you touched on API, application programming interface design there. And I know that's something that's really close to your heart and something you've been working a lot on. So Why is it so important? Why are clean APIs so important? And what's your philosophy behind creating?
Well, APIs, anyone who has seen my talk on APIs know, I believe that they can be your biggest asset or your biggest liability.
Yeah.
A good API is sort of the most successful way to reuse code and to amplify our power as programmers. If we don't have to waste time, reinventing the wheel, we can devote our limited resources to actually solving the problems that we have to solve. So that's the good that can come of APIs. The other thing is that they tie you to the platform with those APIs, so they help a platform achieve critical mass and become what a good platform can become. But conversely, if you have a bad API, it'll be an unending source of pain and costs. Yeah. People will make the same bugs year after year. I can point to particular API design decisions that are responsible for clearly millions of dollars in losses to society and business, just because people do the same wrong thing year after year because the API makes it easy to do the wrong thing and hard to do the right thing. So that's one of those sort of fundamental API design principles. Make it as easy as possible to do the right thing and as hard as possible, or ideally impossible, to do the wrong thing. A good API can literally prevent you from doing some things that you shouldn't do.
So how do you recognize one? Is it a matter of taste? Is it a matter of experience? What is it that makes a good API? How do you know when you've got perfection, as it were?
Well, you never have perfection, sadly. I've never seen a perfect API, but I can tell you when you've got a good one as opposed to a bad one. And to some degree it is experience, it's craftsmanship, but like any craft, there are heuristics that sort of, that experts in that craft generally agree upon. And then the better you get, the more you know when to violate these heuristics as well. So you should obey them unless you have a good reason to violate them, but you can't slavishly obey them, or you will end up doing wrong things occasionally. And sort of there are key properties that distinguish good APIs from bad ones that are fairly easy to see. A good API, first of all, has a small conceptual surface area. You can learn it quickly. That typically means it has a small number of classes with a small number of methods. Or if it doesn't, if it has a larger number of classes, they'll all implement some underlying interface so that you can just learn that interface once and then apply it to a whole bunch of different implementation classes. Right. You have consistency. So every API is sort of a little language, and it has its nouns and its verbs, where, a noun might be element and a verb might be remove or add or something like that. Yeah. And you want to see the API use a small set of nouns and verbs and use them absolutely consistently. And you never want to see two verbs meaning the same thing but being different. Let us say remove and delete, or having subtle differences where the differences aren't obvious.
So even names, the names of functions.
Names are incredibly important. Right. It's funny, I will cheerfully spend hours on names in APIs, and even, by the way, in source code, just getting the identifier names correct, because that is what enables other people to code is read more often than it's written. It's right. Read once and read and maintained for years. So you want to make it easy to read, and you don't want to mislead your reader. This happened to me yesterday on this spec that I was talking about. That contains a grammar for the new integer literals, which allow you to separate groups with underscores, and there were non-terminal symbols that had wrong names. I think they were called like digits or underscores, and sadly both of them could contain underscores. Digits or underscores was optionally separated by underscores, and the other one was separated or terminated. And I pointed out unless we change the names of these non-terminals, the grammar is just going to confuse people. Right. So yes, I think generally speaking, these aesthetic matters are not just being prissy. They have real dividends if you get them right in terms of productivity on down the line. And if you get them wrong, there's real losses in terms of bugs caused by misunderstandings.
Right. So is there a particular API, if someone was looking to design their own API, is there an example that you have done in the past that you would say, I'm proud of this, go look at that?
The funny thing is, there are a number of ones that I'm proud of, but even those have mistakes. Over the years, I can tell you what I would do differently as well. So for example, let's say the thread local API is an example of something which, it's small, simple, clear. It's obvious what it does. It's obvious how to use it. We generified it in Java 5, and it generified nicely, and made a good API even better. So that's one I'm proud of. And by the way, one property that it has is it's obvious in retrospect. If you look at it, you say, of course, Josh, that's obvious, and anyone else could have done it. So so what? But I saw literally, I don't know, 5 to 10 attempts at it beforehand, all of which didn't have that flavor at all. Instead, the flavor they had was sort of a hash table where you provided a key and you got back a value corresponding to that key, and the key was a shared global namespace. Exactly like pthreads. It was, get specifics, whatever. Anyway, the point is that people, they have an API, they know it, and they sort of blindly port it to another language.
Yeah.
But there are all sorts of problems with doing it that way. And as I say, the main one is that those keys become a shared global namespace that has to be administered, and if two people use the same key, then they're accidentally sharing a variable which is intolerable.
Usually leads to bad things.
Leads to bad things, and so, the obvious solution is, well, okay, why don't you preface it with, the class name, which is prefaced with your IP domain name, but that depends on convention. So, well, okay, you can have us automatically assign the keys, and Java actually has the capability to let you give unforgeable keys. Basically, the keys can be objects of some class that is controlled by this package. But that gives you all this unnecessary complexity. And the aha moment is when you realize that the key can be the thread local variable, and you can just set its value and get its value, and all of a sudden, the API turns into something nice.
Elegant, clean.
Something elegant and clean. But that's that's a simple one. I think the collections API is perhaps more instructive because I did a bunch of things right. And a bunch of things wrong. Over the years, I've been able to figure out what I should have done differently. And the price you pay for the stuff that you get wrong is actually very high. So, for example, there were a bunch of methods that I left out of the sorted set and sorted map. And so we had to do navigable set and navigable map, which should really be read as sorted set and sorted map take two, all the stuff that should have been in there in the first place.
Okay.
And so now we have this unnecessary complexity. This is the sort of warts that naturally.
So you didn't just stick an EX on the end of the name.
Oh, well, that would have been even worse, And by the way,
I've seen that
the
done very
methods that
often.
we added really did provide navigation. Right. So navigable map is a somewhat memorable name. So I'll claim that faced with an unpleasant situation, Doug Lee and I, we did it together, sort of did the best that we could. But it's very hard to imagine all of the uses to which an API will be put. You have these sort of failures of imagination. And occasionally, by the way, I've had cases where other people would tell me, you should do this, you should add this method. But one of my sort of mantras is, when in doubt, leave it out. If you can't convince me that it's going to be necessary, it's, there is cost associated with every method, especially in a widely implemented interface. So, when I was doing kind of the absolute base of the collections hierarchy, which is collection, John Rose told me that I should have one method to return an arbitrary element in the collection, leaving it in the collection, and one to return it and remove it atomically. And I kind of asked him why, and he wasn't able to give me a really good answer. He mumbled something about the axiom of choice, and I thought, mathematical geek. And I didn't do it. And it turns out it would have been very, very useful.
Right.
Within a year I started seeing all the use cases that would have been addressed by that. And in the end we addressed them once again with add-on APIs when we did queue and deck, that double-ended queue and so forth.
Right.
Those ones do have these operations, but it's really a shame that we didn't put them in collection.
Yeah.
But I just didn't have a compelling reason to do so at the time. And whenever I'm forced with one of these decisions, if I don't have a compelling reason to put it in, I leave it out.
Yeah.
There are other things where I put things in and I'm sorry I put them in. So, for instance, list is much bigger than so many of the other collections API, and in particular, a list iterator. There's just an enormous amount of stuff that you can do with a list iterator. I shouldn't have done that. It makes it much more difficult to implement list, and in practice, people don't use it very often.
Right. So one of the things that I'm getting is how important it is for people to read other people's code.
Mm-hmm.
To learn things. And so how important do you think the decision was, and how much has it affected the decision of Sun to actually open source when some
I
creators
think
to actually
it was
open source
incredibly
everything?
important. I think the platform never would have taken off. I don't think we would be having this discussion today had it not been quote open sourced. And the reason I'm putting quotes around that is initially I don't think it was open sourced. I think the source was put on the web. Sun retained the copyrights to it.
That.
And I think there were a few people who were personally responsible for it. One of whom is Tim Lindholm, who is a fellow Googler these days. The people who were working on it at the time just intuitively understood that if this code were out there for people to read, they would be able to use it, they would be able to understand it, they would be able to use it as the basis for research, and it would help the platform get escape velocity, which it most certainly did, and did quickly. And I think many successful platforms, took that approach. You mentioned the Lions book earlier. I think one of the things that helped Unix succeed was, once again, that people had access to the source. When I was in college, a long time ago. Okay, so 78 through 82, if you really want to know. I remember, writing a new floppy disk driver for our Unix machine because the one that we had just, put the disk blocks down consecutively, which meant the floppy disk had to very slowly spin around once to get each block, because by the time you wanted to read that block, the head had already passed it. So, I did a little research paper on the optimal skew and interleave for laying data on a floppy disk properly, or any disk for that matter, to optimize sequential access times. And I was actually able to do experiments where I, would change the disk drivers on this system, and this was something an undergraduate could easily do. That would have been impossible if it weren't, quote, open source. Technically, it wasn't open at the time. It was Bell Labs source code, but they the key is it was open in the sense that students could read it and modify it. And I think that was the one very important thing that Sun got right. There are many things which I think Sun got right. Another thing which was astonishing was their decision to put their entire bug database online. When other companies were saying, "What, bugs? We have no bugs." Sun took the entire Java bug database and made it available for everyone to read online. And that was very, very important for people to track issues, to know what was wrong, to know the workarounds.
You're not fighting the platform. You're either fighting your own code or the platform, and you know when the difference is when you can access the bug database.
And these days you expect bug databases to be online, but as far as I know, Java was the first one, so sort of unprecedented. And all these decisions actually can be laid at the feet of sort of individuals with vision. There were people who just said, "Hey, this is something we should do." And they did it.
So, I mean, out there right now, I think, you were saying earlier where we were chatting, that there is it's like a golden age of available source code. Because when you and I were growing up, and I'm not too far after you, there was very little source code to look at. And we talked about the Lions book. The Lions book was actually essentially a stolen photocopy of the Linux source code that was distributed under the underground in book form. I guess just like the old Soviet Union sort of photocopies. Yes, I think the propaganda pamphlets that were passed around, students passed around photocopies of the Unix source code to learn from. But there was very little real source code out there to look at, and now there's just this incredible amount of research quality. As in really, really high quality code to look at and learn from.
And modify and experiment with.
And actually donate back to and work with and build your career on. So how did you get to, be where you are? I mean, sort of what advice would you have for an engineer who's maybe got a few less grey hairs than you have? And, how did your career go, and how did you get to where you are, and how would you advise others to be able to do the same?
The simple answer is find your passion and run with it. I discovered by the time I was 12 that I loved programming, but it was very hard to find a computer back then, and any that you could find obviously took up a room. That was a long time ago, and you just find you find out what you want to do and you do it. These days it's easy. There's an internet, and gosh, every household is filled with computers. And there are all sorts of great projects going on, and there's probably something you're passionate about. With my son, who is 16, it's writing, multiplayer online role-playing games.
Wow. I used to... Back when I was his age, I was learning how to crack games. But.
Yeah. I did a bit of that too,
Yes.
but let's not discuss that.
Maybe not talk about that so much.
The thing is that, well, actually the statute of limitations has expired, so I suppose we could talk about it. But more interesting is what he's doing.
Stuff.
Yeah, he and his friends, they live across a 1,000-mile area, and they just get online, and there are places for them to put their repository, GitHub, or what have you, and there are plenty of high-quality IDEs that they can choose among, platforms that they can choose among, whether it's Java or Mono or what have you, and oodles of good code that they can look at when they want to know, well, how can I do this thing, or how do you use this particular API? My son was doing the networking layer, and he could just find good examples of people using this networking code and learn from them and write his own variants on them. So basically, you figure out what you want to do and you do it. Don't start with something that's too big. If you've never written a program before, don't try to write a network multiplayer game with 3D graphics, because you'll only kind of get discouraged. So
write something that does something fun, visible on the screen.
That you want
immediacy.
To do. And what's incredibly cool? Things that used to would have just been impossible for you to do. Anyone could do. So suppose you have a smartphone, let's say, like this phone device, not to plug one of my company's products, but this is an Android phone, and you can get for nothing, for free. You can download an IDE and a dev kit that lets you make apps that actually run on this phone, and you don't have to...
You could take anywhere and say, hey, look at this cool
thing
I did.
I made it. I did it.
Yeah.
So, DUI Boggle's a bad example because it's already been done. But is there some little game that you like playing that's not on here already? You might not write a sort of a kind of a high production value, professional looking app, but you can write an app that plays that game in a matter of days, and then you've got it on your phone. And you can do it in Java. You can do it in a language you probably already know if you're a geek like I am. I think that's wonderful.
Yeah. I remember the days of having to wait for Byte magazine to turn up, so pour through the listings.
Yes, and type them in.
Yes.
And if you typed, something wrong, and this was, assembly code or whatever, then it wouldn't run. I remember that too.
Yes. You kids don't know how lucky you've got it. Get off my lawn. Yes.
Exactly.
Sorry, we'll stop going into the...
Yes. We'll stop trying to appear older than we actually are.
I'll tell you what we can do.
Okay.
So every good interview with someone who especially has written a book ends with plugging the book.
Shameless plugs.
So let's do some shameless plugs for Josh's books.
All right.
Why don't you hold them? And in fact, these two very books will be available for viewers of this interview to have with a special message from Josh, personally signed. Once you've completed the quiz or puzzle or whatever it is we're going to do to give these away. We decided how to give them away. We haven't decided yet. We'll probably follow up with a little section explaining how you can win these books, but Josh will sign them with the message of your choice.
All right.
Doesn't get further than that.
Yeah. The message, though, cannot be paid to the order of... you've got to draw the line somewhere. Right?
And not your bank account details or social security or whatever.
Exactly.
Yes.
But other than that, anything reasonable,
Yeah, he's a very reasonable man, and they're excellent books. Anyway, thanks very much for the interview. I really enjoyed talking. And I hope our viewers will too.
Well, it's been a pleasure, and happy hacking, everyone.